Greetings, math friends. We are going to look at determining asymptotes in rational functions. So I have a rational function here. We have a numerator that's a function, a denominator that's a function to define a function. An asymptote is an invisible barrier that is in the plane which your graph is approaching, and as your x or your y value tends to infinity, you continue to get closer to this asymptote. Typical asymptotes you might expect to see at the high school level would be a vertical asymptote, horizontal asymptote, or oblique asymptote. And some of these can occur at the same time in the same function. We're going to go ahead and analyze this function and determine the asymptotes that we can. First of all, looking for vertical asymptotes, we are going to take the denominator and set it equal to 0. Solving this for x, we're going to take the square root of both sides. So we see that x is equal to 0. This is the location on the graph where we will see a vertical asymptote. So if you graph this, it's just a vertical line at 0, which is just the y-axis. Next, we are going to attempt to find a horizontal asymptote. Now, to find the horizontal asymptote, there are three options. The degree of the numerator is larger than the degree of the denominator, the degrees are equal, or the degree of the numerator is smaller than the denominator. So when we look at this first one, we are looking for the largest exponent on the single variable that we have. In this case, there is a secret 1 there that sometimes we miss. So this tells us that this the degree of this is going to be 1. When we look at the function in the denominator, we see that it's a quadratic, so this is degree 2. So we have smaller over larger. I have this nice chart that I like to give to my students to help them. This is a set of notes that I give them in pre-calculus to help them with finding asymptotes. We see that we have the numerator is smaller than the denominator. That means that the equation for our asymptote is going to be y equals 0. So now we found the vertical and the horizontal asymptote for this function. The last thing that we could do would be to check to see if there is an oblique asymptote, so a diagonal going across the graph in some way. So the first check that we do for that is looking at this degree comparison. The degree of the numerator would be exactly 1 degree larger than the degree of the denominator. Since we do not have that, we are not looking for an oblique asymptote, so we have found the asymptotes that we are looking for this function. All right, we're going to take a look at a second function. We have g of x is equal to 4 times x cubed minus 5 over x squared plus 8. So again, we can go through and check for the 3 basic types of asymptotes here. So we can look at vertical first. We're going to set the denominator equal to 0 and solve. bring the 8 to the other side, we have -8. If we take the square root of that, we're going to get a complex number. No vertical asymptote here. The next thing that we do is we look at the degree of the numerator versus the degree of the denominator. At the top, we have degree is 3, since we have a cubic, and then we have degree 2 in the denominator, since it's a quadratic. So we have the degree of the numerator is larger than the degree of the denominator. So if we check our 3 options, we see that the horizontal asymptote does not exist. Now, also looking at this, we see that the degree of the numerator is exactly 1 larger than the degree of the denominator, which means we will look for an oblique asymptote. To do this process, we are going to do division. We are going to set up for long division. It doesn't meet the requirements for synthetic division since we have this quadratic term in the denominator. The first thing we do with a long division is we make a ratio of the first inner term to the first outside term. So we have 4x cubed divided by x squared, and that is 4x. That's part of our quotient. And then we multiply this by this as we would do in a normal long division. So 4x times x squared plus 8. And that is going to give us 4x cubed plus 32x. Now, we are going to subtract this from what we have. This is where trouble can show up. Because we are subtracting polynomials, the negative of the subtraction is distributing across this second polynomial. So it effectively is a sign change for both those locations. So now I'm going to add these columns. We expect that this first term is going to 0. We're eliminating this as we do the division. We end up with negative 32x minus 5. And we are going to continue this process. We're going to create ratio of the inside first term to the outside first. When we look at this ratio, we see that it is essentially a proper fraction since the degree of the numerator is smaller than the degree of the denominator. That's how we know that this actually is the remainder. As we look at this, the linear portion that leads this quotient is the equation for the oblique line. So this is the equation for the asymptote that we find for this particular function. Hopefully this has been helpful in helping you determine these 3 basic types of asymptotes that you might encounter with rational functions. Cheerful calculations.